In this lesson, we're going to compare and contrast the various storage types available to us in AWS. Many options exist, and each has their trade-offs with regards to cost, performance, ideal use cases. Know and embrace the limitations of each, and keep up to date on developments. For example, Glacier came out right when I was in the middle of teaching a class on S3. AWS changes very, very quickly, and it's important to keep up to date on developments and make sure you're not reinventing wheels. We're going to look at S3, which is also known as an object storage. We're going to look at RDS, which is Managed MySQL, Oracle, or SQL Server. And we're also going to look at DynamoDB, which is a NoSQL database. First up, let's look at S3. S3 is object storage. You put an entire object into S3 and you can pull it back out. It's not really useful for editing objects themselves. It's great for static assets, however. RDS, or Relational Database Service, is a hands-off RDBMS for MySQL, Oracle, and SQL Server. It's manually scalable, like EC2. DynamoDB is a column family-oriented NoSQL database, which deals awesome with the 3 V's of big data: variety, velocity, and volume. It's very hands-off and very, very simple to scale. The value propositions of S3 are that it's basically a Swiss Army knife of static storage. It's always the cheapest option to both store and serve data, way, way cheaper than serving out of your EC2 instance. There are no limit on the number of objects that you can create. It requires no pre-provision in size. It's extremely durable, having 11 nines durability. This essentially means that if you store 1 million files in S3, you're going to lose one of them every 10,000 years. It achieves that durability by leveraging multiple nodes in multiple availability zones. So when you put a file into S3, you're actually copying it many times into many availability zones. It's also very scalable. Because it exists in all those places, when users go to access it, they can pull from several disk heads at once. All objects are natively web accessible, and it can also host static websites. There are some limitations on S3 you need to be aware of. It does come with higher latency, especially if you're talking about EC2. It's always going to be faster to access ephemeral or EBS disk than S3. It is a write once, read many file store, meaning you put an entire object in or you take an entire object out. You can't really edit objects. It also cannot serve dynamic content, such as PHP and Ruby. You're limited to 100 buckets, and no object can be larger than 5 terabytes. These are hard limits, and you cannot change them. It's very bare bones and essentially just provides read, write, delete, list, and so on. If we look at the value props of RDS, it's essentially a managed MySQL, Oracle, or SQL Server. MySQL is the most feature-rich, including the support for read replicas. High availability is baked in. It has multi-AZ master and slaves. If we look how it's deployed inside of a region, we have a master on the left availability zone with a hot standby slave in another availability zone. Disaster recovery is also baked in with backups and real-time snapshots. It's very cost-effective, way lower cost than a roll-your-own EC2 plus MySQL, for instance. You can also bring your own license or BYOL with Oracle and SQL Server. It's very scalable and provides scaling with instance types like EC2 and provisioned IOPS like EBS. It does have an upper limit on vertical scale. You only get a single instance of RDS and you can't horizontally scale it. It has a 3 terabyte max database size and a SQL client-only interface. You get no direct SSH access to the box or ability to control hardware. If you do need direct control, you want to consider using EC2 and installing your own RDBMS on top of it. DynamoDB deals really well with the 3 V's of web scale, which are variety in the types of data that you're storing, the velocity or how fast you want that data served. DynamoDB is backed with SSDs and extremely fast, as well as volume. You can store very, very large tables inside of Dynamo. It's a column family key value store. It is also very strongly consistent. It's managed, and the high availability is baked in. Inside of a region, when you deploy DynamoDB, you're actually deploying to multiple availability zones. And every time there's a change inside of one of the data points inside of the availability zones, it's copied to all others in the cluster. The scaling is also baked in. It's tuned via independent read and write throughput. It's very cost-effective and very, very easy to administer. It automatically repartitions your data on the back end. It supports 2 lookup key types, a hash key or unique ID, and a hash plus a ranged key, which is typically a date. It does have a very limited querying capability. You're only able to look up on a primary key, that hash or hash plus range. The only operations you can do are get, put, update, batch write, query on the range, and scan, which is typically not a good idea. It does, however, come with no limit on table size and allows you to scale to very, very big volumes. It has a 64K row limit size, and it also has probably one of the most complicated but reasonable pricing models inside of AWS. There's no limit on throughput, and it's provisioned by the user. You obviously pay for higher limits. If you compare these systems to each other, when you have static files and backups, you want to be thinking of S3. You probably also want to consider setting up a CDN through CloudFront. If you have RDBMS type interactions that require ACID compliance and/or the ability to run various queries, you probably want to look at RDS. If you have a 3Vs issue with very big or very fast data that you need to serve, you probably want to look at DynamoDB. There are use cases for each of these services, and you'll see that inside of a single web app, you may want to use all 3 together. For example, you may store images, CSS, JavaScript, and HTML in S3. You may want to store orders, customers, and data that you want to ad hoc query later in RDS. And you may want to pull hot tables, such as social interactions and likes, out into DynamoDB. You could then use a unique key, such as user ID, for the primary key in Dynamo. Let's cover some things that you probably never want to do with these different storage models. Serving content out of anything besides S3 is just silly. It's going to be slower, more expensive, and less redundant. If you try to make RDS do web scale, you're going to run into a lot of problems. At the very least, try to pull hot tables out into DynamoDB. And if you're trying to use DynamoDB for anything but web scale or those 3Vs, you're going to find that SQL is better understood, more flexible, and probably your better bet. Rolling your own without good reason is also not a good idea. The AWS service will probably be easier to use and manage, not to mention cheaper. A storage model that we completely gloss over inside of this course is SimpleDB. SimpleDB is a NoSQL data store that preceded DynamoDB. It's still inside of AWS, it's just not very performant. The reason for the lack of performance is that it indexes on multiple fields, and every time it indexes, it slows itself down a little bit. DynamoDB is the preferred way to deal with NoSQL now. SimpleDB still has a dwindling number of use cases, which pretty much limit it to internal applications. Some customers decide to install their own RDBMSs because they either really need the control or they need to grow beyond that 3 terabyte limit. Some folks also decide to install their own NoSQL database, such as MongoDB, Cassandra, and HBase. If you need a large distributed file system, you can also accomplish this by tying together many EC2 and EBS volumes via something such as GlusterFS. In closing, just make sure that you understand the trade-offs and limitations of each type that you're using, and make sure you're using it for the right reason. If you are going to build your own, make sure that you consider HA, backups, failover, durability, and the lack of native integration to other AWS services.